Right? The simplest object in three-dimensional space is the subject you always see. If there is an object, all you always see, and that is a rectangular box. Okay? So you're given, this is also in mathematics called prism. Okay? This is a rectangular box. Now, what we should know about the rectangular box? I think we should know how to calculate the surface area, right? And how to find the length of the diagonal, which is d, okay? And how to find the volume. Okay, we have to introduce a new concept, which is called the volume, because it's a solid. We can talk about volume, okay? And volume tells you how much stuff there, you know. It's very important measurement of a three-dimensional object, right? Besides the surface area, okay? So let's find out. So first of all, this is a definition. It's not a formula, okay? Definition. The first time we call it volume. Volume is a product of the length, width, and the height. Okay. And we don't call it a formula. It's actually the definition for the volume. Okay. For the volume of this rectangular box. Now, the other stuff where I'm going to talk about is called formula and how to find the surface area. How to find the surface area. How many faces is there? 6. More than 6, right? 6, yes. You have a front and back side. The front side is A times C, right? So, and then back side is also A times C. So now you have twice. Then the left is right. Left side is B, C. The right hand side, the face on the right hand side. The face on the left hand side is also B times C. So that is the area. Okay. Then the bottom part is A times B. The area of the bottom, area of the face at the bottom, area of the face of the top is also A times C. So it's twice of AB and twice of BC, twice AC. Okay. Now here's come to the length of the diagonal. How many diagonals are there? I mean, several of them. They have the same length, right? Look at the picture. Now you have to derive this formula. Okay. How do we do that? Well, you can draw the line here, and you get a vertical right triangle. So you apply the Pythagorean theory twice. So this is this is A, this is B, this is my X, right at the bottom. This is a rectangle at the bottom of the box. Okay. Then X squared equals A squared plus B squared. That's Pythagorean theory. But we also have there's a right triangle standing there vertically, right? The bottom part is X, the side is B, the hypotenuse is D. So D squared equals X squared plus C squared. So now clearly D squared equals X squared is A squared plus B squared, right? Then plus C squared. So this is a three-dimensional Pythagorean theory, actually, right? All right, so that's it. That's all we needed to know about the rectangular box. Okay. Another important algebraic identity is A times B times C. Okay, what is that? Okay, how can I find that? How can I expand it? Well, this is just, if you don't know, then A plus B, then you multiply this out. Okay. So let's see, A times A is A squared. A times B, AB. A times C, AC, so 3. Then B times A, B times B, B times C. Then C times A, C times B, C times C. Okay, total, you have 9 terms. But you see that A, B, B, A is the same, right? So you can put together A squared plus B squared and 2AB, 2BC, 2CA, okay? Are you familiar with this? This is this is actually the surface area, right? This is actually the surface area. This is the length of the diagonal. This is the surface area. Right? This is the surface area. Right? So this is very important. And A plus B plus C is going to be a quarter of the 1/4 of the total length of the total edge lengths of the rectangular box. Okay? Maybe you can call the parameter, but this for the solid. You cannot talk about parameter. You can talk about the total length of all the edges. Right? So this is A plus B plus C. So what is total length? The total length of all edges. Okay, how many edges here? 1, 2, 3, 4. Okay, or the 4 vertical edges. Okay, and on the top also it's 4 edges on the top, 4 edges at the bottom. So it's 4 plus 4 plus 4. It's come on, it's 12. Okay, so 3 times 4. Okay. 4 threes, in other words. Okay. And but you only have a different 3 edges. So actually 4 threes is 4 times A plus B plus C. Okay. Right. It's the total length of all the edges. Now, it is this is the formulas, and we can use it. Okay, so it's a special case. It's a cube. Let's take a look at the cube. The cube is all the edges are same. Okay, so the volume is going to be A cubed, right? The surface area, how many faces there? 6. 1, 2, 3, 4, 5, 6. So 6A squared. The total length of the edges, maybe I call the P, right? P is a parameter. So P is going to be 4 times 3A, so it's going to be 12A. So because the 12 edges there. Right? So this is about the cube. But the length of the diagonal, so D squared equals 3A squared. Okay? The length of the diagonal is given by this. All right, that's all we needed to know. Okay. So here's a question, okay? If the diagonal of a cube is 5 square 3 long, I forget the units, okay? What is the volume? Now this is pretty straightforward. This is a two-step problem because the volume is going to be the cube of the edges, edge length, right? But edge length is not given directly. So what we are given here is we're given D. D is a 5 square 3. Okay, we want to find out the volume. Volume is A cubed. So we have to find the relation between A and D. So then you can solve the problem. Okay. So the relationship between A and D is D is going to be square 3 times A. Right, by this identity. Right. Then you will see that square 3A equals 5 square 3. So A should be equal to 5. So the edge length is actually 5. Then you can find the volume A cubed, the 5 cubed. Okay. That is good number. Okay, 125. So my next problem is maybe I wanted to find, okay, the surface area. We know the surface area cube. Okay, I want to find out other information about the cube. So surface area of a cube is 72 square feet, for example. Okay, what is the volume? Right? Are you able to figure it out? Yeah, try this. Yeah, you're not given the data you needed to find the volume. The volume formula, right, is going to be the product of all the edges, 3 edges. So they are all 3 identical edges. Then you can say a cube. But what is the edge length? So you have to find the edge length first, right? Right. So Nathan, give me the answer. Right. So to solve this problem, when you do the problem, right, when you do the homework, I suggest you draw the picture, okay? So it's clear, you know, you write down the surface area is going to be 6a squared, and you want to find out the volume, right, which is a cube. Okay, it's very clear, right? Given the surface area, which is 72. So a squared is going to be 72, but divided by 6, okay? 72 divided by 6 is going to be divided by 6, right? Is going to be 12. Right. So a squared is 12. So what is a? A is a square 12, which is 4 times 3, 2 square 3. Right? Then the volume is a cube. A cube is a square times a, right? You already know a square is 12. A is going to be 2 square 3. Okay? So it's 24 square 3. And that is a cube. Right. That's called a two-step problem. Okay, the next one is pretty tricky, and I always ask you to do this problem. So this is a rectangle. You're not given the dimension of the rectangle, which is the edge length, width, and height. What you're given here is, okay, you're given here is 12 square centimeters, and 15 square centimeters, and 5 square centimeters. That's much smaller. Okay. Can we find the volume? First of all. Second, find all edge lengths. Okay. When maybe you can do opposite. You find all the edges first. Then you can find the volume. Right. This is the ShenMathClass problem. Right. Yeah, with the mass contest, and maybe with different numbers. So, have any ideas? Please try this first. If you get answers, please post it. Okay, we have several students here today. I'm not sure everybody can figure it out by yourself. within given time. Austin Lu, coloring John, coloring. I haven't heard from you for a long time. I hope you figured out how to do this problem. Nansen Yang, William Ma. So if you have answers, post it here too. Just find the volume first. Now the question, I think it's easier to find the volume first, then find all the edges. I think Alex Nansen's answer, Nansen Zhang's answer is okay. William Ma's answer is different from the rest of them. So William, you have to double check your work. Okay. So I have A, it's difficult to by guessing trying to see what is ABC, right? So we are given the following information, given A times C is 12, and B times C is 5, and A times B is 15, okay? What do we want to find out? We want to find the A, B, C, and the volume A times B times C. So the majority of people trying to find the ABC first, but this is really quite special equations. What I'm trying to do is I find the volume first because A is going to be the volume divided by BC. You already know BC is going to be 5, so volume divided by 5 gives you the area there. Okay, and the B is going to be volume divided by AC. So AC is going to be 12. C is the volume divided by AB. So AB is 15. Okay. So you can, as long as you find the volume, you are able to find the individual edge lengths. Okay. Okay, let's find the volume. The volume is A times E, B times C. But without finding the individual value of A, B, C, how can I find the volume? Well, A, C, B, C, A, B, if you multiply them out, right, it's going to be 12 times 5 times 15. But the left-hand side is just A squared, B squared, C squared, which is a volume squared. Okay? Right, so volume is going to be square root of 12 times 5 times 15. The question is, how do you simplify? Well, 12 is a 4 times 3, 5, and 15 is a 3 times 5. So you have a double 3, double 5, right? And then 4. So 4 is 2 squared, so it's 2 times 3 times 5, and 30 is going to be the answer. Okay, so once you find the 30, then you use above formula to get A, B, C. Okay. Yeah, this is a very interesting example. Okay, our next problem is about, okay, here's a 5 by 5 by 5 cube. Is paint, okay, first of all, it's a faces, right? And then cut into 125 small one by one cubes. Okay. So there are some faces of the cubes are not painted. The question is, what is total area of unpainted faces of all the small cubes? Okay, so draw the picture, right? This is large cube. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Well, it's hard to see that. Okay, so anyway, this is a cube. Okay, it's 5 by 5 cube. So we cut it into many small cubes, one by one. Question is, how do we calculate unpainted faces? Total area for unpainted faces. Okay, and you after you cut them, you get those little cubes. Some cubes have only 2 faces are painted. Okay, if you have ideas, please let me know. Well, we have lesson song. So he figured out. Answer. William, are you sure? Yeah, William, you need to pay attention. The answer you give to me, that's not the correct answer. Terry, are you there? Okay, YSE. Yes, okay. All right, yeah, please find a good way to find the area surface, because otherwise there's just too many little cubes there, right? So some faces are not painted. You know, the direct way will look at all those little cubes, and then count those faces which are not painted. That's too many. Some cubes have has a 4 faces not painted. Some cubes have 5 faces not painted. Some cubes, you know, all the faces are not painted. So if you solve the problem directly, you're not able to solve it. So study mathematics here. I tell you, this is, you can say it's mathematics. Actually, this is a, you know, this kind of problems make you, if you can do it, make you smart in the future when you solve the daily problems. Okay, there's so many problems you needed to solve. Even, you know, if you own the house, sometimes some part is broken, right? You probably can find a very clever idea to fix it. Okay, so this is a kind of a training. Not only just, you know, this will be used to you know, in the future. Okay, but this kind of training is very important for your future. Okay. Okay. So anyone has different answers? Has answers. So William, your answer is wrong. Okay, cannot be that small number. Right. So many cubes inside. All the faces not painted. And that's obvious. So the numbers should be bigger than 100. Clear. Yeah, so now this answer is correct. We have one Indian student here. All the students are Chinese. Good job. All right. Harry. Okay. So your number is smaller than William. Okay. 25 definitely wrong. Okay. I said it's more than 100. Right. So how do you solve this problem? The idea is it's very simple. Okay. Okay. This is a cube with all the faces are not painted. Some cubes only the one side of face are painted. Okay. If, for example, if this is I'll give you an example where is it from. If this is for that one, right? It's only one face is painted, right? If this is for example this one, okay, on the edge, and then two faces are painted, right? Okay, and the one inside, okay, inside, it's all the faces are not painted, unpainted. Okay, the one at the corner. When at the corner, this is three faces are painted, okay, right? So it's pretty complicated, you know, at the corner, right? Three faces will be painted. All right, there are lots of cases here if you solve the problem directly. That's why I keep saying that if you solve the problem directly, it takes too much time and it's easy to make mistakes. So what I'm going to do is I find that the total area of all the faces of the small cubes. I find the total surface area of all faces of all small cubes. Okay. Question is how many small cubes there? 5 times 5 times 5, right? You have this many cubes, unit cubes. For each cube, the surface area will be 6 times 1 square. Right? So that is going to be 750. Okay, including those faces which are painted. Okay, now can you figure out the total surface area of all painted faces of small cubes? Yeah, when you try to find the surface area of all unpainted faces, another way you can do is to find the surface area of all painted faces. And you take a subtraction, okay? Yeah, you do a subtraction, then you solve the problem, right? So, but it's much easier to find the total surface area for all painted faces because all the painted faces are small cubes. They're all coming from a portion of a face of the larger cube, right? Because this side is painted, and it must be from here, okay? So that's why this is just equal to the surface area of the larger cube, okay? And the larger cube, I know that 6 times 5 square, right? 5 square is a 5 times 5 is a face. If the area of the one face, and multiply 6, you get 6 faces here. Okay, and that is going to be, I think it's 150, right? 150. Right, so the answer is going to be 750 minus 150, 600. Why is minus? Because you're talking about the total area of unpainted faces. That's why it just takes a subtraction. All right, so you needed to learn use subtraction to solve the problem. Okay, don't just focus on focus on all the faces, painted, unpainted faces. It's difficult. So subtraction method is a very useful method. For example, if we have a square, right? I choose a point. I choose here as 1/3, here's 2/3, 1/2, and then maybe here as 1/3, 2/3. I just randomly draw the picture, okay? Now, what is the area of that triangle? But if you just focus on the triangle, it takes a long time to find the answer, and it maybe cannot be simplified. Okay, because it's not like a triangle, it's not the equilateral triangle. Who knows what kind of triangle it is, right? Right? Right. So you cannot easily find the area of this triangle in yellow color. Okay. What you should do is use subtraction method. So you find the area of the square and then subtract the area of all the figures surrounding that triangle. Then those are the right triangles or trapezoid. So it's easy to find the area. Okay. So the area of the triangle, right? Area of the triangle is going to be, this area of the square minus the area of this triangle, which is 1/2, right? Times 1/2 times 2/3. Then the area of this triangle minus 1/2, 2/3, and times 1/2. And minus the area of this trapezoid, right? The bottom part is 1/3, the top part is 1/2, and times the average value times the height is 1. So you will get a fraction quickly. Right? So you know how to simplify, right? Yeah, someone already did that. Alex already did that. Okay, so I don't need to waste time to simplify this. All right. My next problem is in a rectangular box, which is also called a prism. Right? If the length of diagonal is a square 14, and the total length of all edges is 24. Can we find the surface area? Yeah, this is another difficult problem, but you have to draw the picture and show it to me, okay? Step by step. So I'll give you 1 minute to think about. We have plenty of time. Right. I hope you solve the problem. And then go back to the notes if you forgot, okay, the formulas. Yeah, if we need help, I show you the picture here, right? So this is A, B, C, and this is a D, right? And D is given, right? The total length, the total edge length is 24, and the length of the diagonal, D is a square 14. The total length A plus B plus C divided by multiplied by 4, that's the total length. It's going to be 24. Okay. Okay. Please work out this. All right. Wow, Nathan, good job. Nathan has answered for this problem. Anyone else? All right, we want to find out the surface area. Right. I'm not sure Nathan's right answer is correct, okay? But at least he has answered it. All right, anyone else? So right now, what you have to find out, you have a surface area. So you have to find out the surface area was 2 AB, BC, and CA. But once you see that, you should remember the formula we did, right? So we have A plus B plus C squared, and that is going to be A squared, B squared plus C squared, 2 AB, BC, CA. So this is unknown, right? This is unknown. Everything else is known. Okay. Well, I already give you this so much information. Are you able to pick it out? William, calling your name. Okay, show me. This is the algebraic problem. Okay. How about Nancy Young? You haven't shown me anything yet. Are you there? Okay, good. Yeah, look at this identity. What are you given? Come on, just plug all the numbers into the formula. And then you get an unknown, okay? This unknown part is the surface area, right? Alex, Nancy Zhang, and Terry, you all give me different answers. At least the two of you get one answer. Can you continue work on the problem? All right, so what is a plus b plus c? Well, that's a 6 because 4 times a plus b plus c is 24. So 6. A squared plus b squared plus c squared, that is going to be the square of the diagonal. So 14. That's it. This is the surface area. A equals 6 squared minus 14. 36 minus 14, 22. Wow, Alex Zhang gave me the right answer. Congratulations. Okay, let's continue. Not a big deal. Okay, a rectangle box. I know that. Let's redo the. Now let's try different problems. Okay. Okay, I have 4 cubes. Okay, 4 cubes of volume. Okay, they're given 1 cubic centimeters, 8 cubic centimeters, 27 cubic centimeters, and 125 cubic centimeters. Okay, they are grouped together. Now the sum of the edge lengths, yeah, we're talking about the previous problem, right? Yeah, the total edge length is 24, but a plus b plus c is going to be 6 only, because 4 times a plus b plus c is going to be the total edge length. All right, so those cubes are glued together at their faces. Right? What is smallest possible surface area of the resulting solid? All right. So how do you glue them? You want to make sure the faces, right? This is the largest one, might be right. It's a 5, 5, 5, and then put this next one, 27. What I'm going to do, maybe I'm going to put it here, 27. Okay, 27, 3, 3, 3, right? Right. And how can I make it 8? 8 is even smaller. Yeah, it's not easy to draw 3D. Right? Then how can where I should put the unit cube? The best place to minimize the surface area, the best place you can put it here. Right. All right, now they all glued together. Then the resulting solid, the resulting solid, I don't call it figure, okay, resulting solid, what is the surface area? How do you find it? Okay, can you figure out the surface area? Well, right. So you have to be careful. Delete those. First of all, the surface area, right, is the surface area of of the larger cube, so 6 times 5 squared. Then you needed to subtract something, add something, right? Okay. So there's the one common, let me, this piece, right? This piece have to be delete. So it's minus 3 squared. Okay. Yeah, what I'm trying to do is find, maybe I can find all the suppose they're not glued together, then I delete the common part. Okay, how about like this, right? Very much easier to understand. Yeah, the larger cube, that's the surface. Suppose they're not glued together. And 6 times 3 square, and 6 times, I think a 2, the other one is 2, right? Edge 2. 2 square, and plus 6 times 1 square. Then you have to delete the common part, right? Twice, because like the yellow one glued together, right? When they're glued together, this piece is not counted as a surface area, so it should be twice times 3 squared. Okay. Then also minus twice of 2 squared and minus twice of 1 squared. Okay, but those are the faces, the yellow faces. Was the larger cube, but then you have to take care of the cube, right? This part, right? This shouldn't be included. And then that's 2 faces here, 2 times 2 squared, right? Okay, and then it's 2 times 1 squared, because this part is also here, right? All right, the only last one is going to be the one between the 2 smallest ones, I think, right? So it's minus 1 squared. Okay. So be careful when you delete all those. All right. The final answer is 194. Did I forgot how many cubes here? I did not forget, like 1, 2, 3, 4. Larger one, this small one is 1 by 1, right? Yes, okay. Yeah, okay, so I have 4 cubes here. So first of all, is they're assuming they're not glued together, you get total surface area of these 4 cubes. Then you have to subtract the common one, okay? So first of all, this is on the larger cube, right? So it's easy. Only consider those overlapping faces on the larger cube, okay? On the larger cube, right? Then you consider the vertical region, right? On the 3 by 3 by 3 cube. Right? Then it's almost gone. We consider the last one on the 2 by 2 by 2 cubes. Right? So add them together, you get this. All right, I'm going to last few minutes, I'm going to talk about the volume formula again. Yeah, take a look at the box, okay? Here's A, here's B, here's C. So remember the volume formula is A times B times C. But let's view it as the following. It's A times B times C. What does that mean? A times B is the area of this base. Okay, this area is A times B. So A times C. So that means the volume is going to be the surface, the volume is going to be the face, the area of the face at the bottom, okay, times C. C is the kind of height of the solid, okay, right? Now, if I cut it into half, okay, so right? So you have A and B and C. So the volume is only half of ABC, right? Right? It's only half of the ABC. Right? Because this is you cut the person along the diagonal, along this diagonal into half, into two halves, right? But one half of AB is this part. So that is the area of the triangle, A times B, right? This is right angle. So this is also A times C, okay? So let me introduce the concept of cylinder, or cylindric solid, okay? Cylindric solid means you have a region, in a two-dimensional cross-section, and so they are consist of lines, and all the cross-section the same along the, if you use a parallel planes to cut off, okay, all the cross-section are congruent. By parallel planes, right, are congruent. Right. This is also called a cylinder, and that's the definition of cylinder. And if the height is h, and the area, this is the area of the bottom, the cross section. Right? Because they are all same. So you can say this is the area of the bottom part. Right? Then the volume, V, is going to be just A times H. Okay? H is the height. Right? You may call the formula, but you can derive this formula using more advanced mathematics. So that means this is important, only depends on height, not the line, not this line, the length of this line. Okay, so if you have a two plane are parallel, so we assume that they are parallel, okay? And then I have a cylinder, circular cylinder, right? And also have another cylinder, okay? It's also circle, the same circle, but I draw the line like that. And this is a vertical. I'm surprised, as long as the cross section is the same circle, okay, then they have the same volume. Yeah, it does not look like that, right? It sounds like like this one is very long. You know, they should have a more volume, right? But this is by the formula, because two lines are parallel, the height is the same height, the base is the same base, so the volume is going to be A times H. Actually, this piece get more slim. Okay, when you move the circle, this is a circle. Okay, this is circle, same circle on the top. If you move to the side, far away from the center. Okay, this phenomena We already know that. Even the area, you know, two parallel lines, right? Okay, so this is a triangle, and this is another triangle. Looks like this is a very long triangle, but they have the same area, right? You know why? You know why? Because by the formula, right? It's a base, the same base, height, the same height. A equals half of the base times height, right? And here, this is a volume, right? Volume is going to be the base times height. Okay, so that's why, you know, they have the same volume. Okay, the second picture they have the same. This triangle and these two triangles have the same area. And the prism is special cylinder with the cross section, rectangular cross section. Okay, but I just said that this could be triangle, you know, could be circle, right? It's a cylinder. If it's a circular cylinder with radius r, right? And this is height. So the volume is going to be, right? Base area, A, the height is h, right? So the base area, okay, it's going to be pi r squared and h. Okay, so the area of the circle at the bottom times the height, that gives us a volume. Okay, that gives us a volume. Let's do one more. Let's do one example. Okay. Yeah. How can I show it? Okay. I have a rectangular box. Okay. I have a circle inscribed it, and this is a cylinder. Okay. The cylinder is inscribed in a prism. Okay. Was a square base. Okay, so that's why the cross section is a square, and then you have a circle, right? Otherwise, you cannot square. The circle is not inscribed in the square. All right. So I find the ratio. Okay, this is the volume of the cylinder. Okay, and here's the volume of the prism. Okay. Well, to solve this problem, you just needed to find out that this is the h. You just name the variable. That's not be used. Okay, and this is side A, this side A is the radius, right? I is going to be half of A. Okay, so the volume of cylinder is going to be the volume of the base, pi r squared times height, and the volume of the prism is going to be a squared times h, right? H will be canceled out. It's really independent of the height. And we also know the relationship between I and A. So it's going to be pi a quarter, a squared, cancel out. It's pi over 4, which should be less than 1. That's true, okay? Because the cylinder is contained in the prism. Okay? So the answer is pi over 4. Great. let's stop here. And next class, we're going to spend more time on cylinders and sphere even, okay? And you know, prism, for example, okay? Prism and pyramid, yeah, pyramid, cone,